Hi everyone, this is JB, and I'll be talking about widget and integration testing in Flutter today. This is for DroidKaigi 2020. Let's begin. For example, you have an application. Let's say you want to track all the movies that you've watched recently, so that, for example, you can avoid rewatching it if you forgot, or if you can track how many times you've watched Friends, for instance, and brag that about your friends. And let's say you made a movie tracker app, which tracks all the movies that you've watched, including the dates and how many times you've watched it. And he added some few features, for example, signing up and logging. You can see that on the right side. You also want to list your watch movies. For example, here I watched My Little Pony and a Flutter movie from 2014. And for that, you also want to add a watch movie here, which fetches from an online source, searching using a keyword, and then you can select which one you've watched. And you can also filter from the list of your watched movies. So for example, I had 3 movies that I watched, and I'm trying to find space movies. And so I typed space. This is good, and for example, you've already made the application. And more often than not, when you test it, it works. But then when you start adding features, you would encounter things such as missing features that you've implemented before, or it causes some bugs from a previous feature. You can avoid that by adding tests. And usually we add unit tests because they are quite simple, they are very maintainable and reliable. Aside from unit tests, there are several kinds of tests that Flutter provides and some other platforms provide as well. We can see here that in Flutter you have 3 different kinds of tests. On the left end, which is unit test, gives you low confidence on your results, but also a quick execution. And on the right side, which is the integration test, it gives you the highest confidence that you can have on your test for Flutter, which also leads to the slowest execution speed of your test. Some analogies that you can make for unit tests is actually the XE test for iOS and JUnit 5 for Android. So they are quite similar. And this talk is actually not focusing on unit tests, so we'll not be focusing on that. But for integration test, it's similar to XE test for iOS, which is the UI testing framework, and Espresso tests for Android, so also a UI testing framework for Android. So you can say the integration test in Flutter is actually a UI test for Flutter. And Flutter has introduced something new, which is the widget testing. And it's in the middle of these two. So it gives higher confidence on your tests, but it's also still quick to execute. It does it by running the Flutter application that you've made in a simulated environment. So it doesn't run it on the simulator or emulator or the device. It runs it on an environment where it can render the widgets and where it can find and verify if those widgets are working properly. We'll get to that in a moment. So you have your app and you want to add, for example, test if you want the login to be working. Let's go back to the app and, for example, you have 2 unit tests for filtering of movies, and then suddenly when you're trying to use it, it doesn't work. As you can see in the photo here, the unit test will verify that these 2 windows are working properly, but when you use them together, it doesn't really work. So for that, you would want to add an integration test. At the end, we have something like this. As a result, we want to test if you can sign in, so log in to the application. And you also want to test if you can create an account. So these videos show that at the end, we'll be able to make an integration test that you can run in Flutter that logs you in, it's quite fast, logs you out, and then creates your account, and then brings you back to the main screen. So that's running in a very fast time frame, but we'll show you later on that you can even make it a little bit more faster than that. So let's go back to adding the integration test. When should you use it? So if you want to run the application that you made on an emulator or a device, you can use integration test, because the unit and widget testing for Flutter does not run them on the actual emulator, simulator, or device. And if you have complex flows, for example, if you have login, calling the network, having some fields, and possibly displaying some alerts for errors, for example. And for example, there are navigation elements that are hard to mock. You can use integration testing. Or if you have a checkout page, for example, if you're buying something in a shop, then you can use integration test. Another good use for integration test if you want to measure performance of your app. So for example, for your movie tracker application, you have a list of movies that you've watched. If it's a really long list, you still want to verify if the user can scroll through the list without it lagging or without it hanging. So in order to provide a consistent user experience, you can do this by monitoring the performance of your application, running a scenario where you are dragging through the list, and verifying how fast it renders the list, and checking if it's within a range so you can maintain the performance of that scenario or several other scenarios. So now that you know when to use the integration test, let's set up some tests. I put some top-level overview of how integration tests work in Flutter. You have the application under test in the middle, and you add a driver on top of it. So when you run your integration test, the app you are testing is actually running wrapped around inside of another thing that will drive the application. So it will, for example, find where the button is, and then click on that button, and then, for example, another field, click on that field, type on it, or drag and drop stuff, and verify if things are existing or not. And so you would want to add the Flutter driver dependency for this. Let's go through the project here and see that we have no dev dependencies currently. And you would want to add the Flutter driver dependency. So here, I've added the Flutter driver dependency and the test dependency, which you would need later on. And then you can create the test files. Going through the documentation from Flutter, I've realized that they have some preferred structure, which is to add it in the top level directory here, for example, test driver, and then create test files, which is, I've created already some of them, the application that you want to test, the file which contains the tests. Right now they are empty with some static strings. And then I made a class for mocking of the classes that we would need later on. As you can see, we are missing this Mockito dependency, so let's just add that. There, now we've added it. And let's go back. So now we created the test file, so we need to instrument the app. So now we have this app.dart here. How it works is it has this main method, which gets called when you want to start the application. And within this main method, you want to start the actual app. So our actual app lives in main.dart. And it's running it using this run app command, actually. And so for us to run the whole application for integration testing, we want to call the method that runs this. So it's either you run this directly, or you can also use the main method so that your setup here is also run. For example, I'm configuring Firebase, and I'm configuring some error handlers. I want all of that. So I want the main method here to be exported, and I do that by importing main.dart file here, and I call it app, and then I call main. So that will run your application. And then when you want to add the driver, you call enable Flutter driver extension. And that should run the driver when you run the integration test. The next step is to write your integration tests. So I have some empty methods here already. I've grouped them into one and have two tests. One is to log in, verify that the user can log in. The next is to verify if the user can sign up. Let's delete this first. And after you write it, you want to run the integration test. So let's begin writing one of them. Let's start by logging in. Let's follow a pattern where you want, so you have given, then, or when. So for logging in, I think what you want is, from the welcome screen, you want to click on the sign in button. So given you click on the sign in button, then you would want to enter a password, enter an email, enter a password. And then when you click on the login button, then you want log in. Also add some additional checks that before you click on login, you are logged out. So let's go through them one by one. First, you click on the sign in button. How do you do that? So first you have to find the button here, or here, and then you click on it. So let's introduce the concept of finders. Well, before that, sometimes you would want to communicate between the application and the driver, and it's called a handler. And we'll show you that later on. So let's go to the concept of finders. These are methods that allow you to find widgets. For example, using a key. So here we're using a value key. Let's try that. So you want to find the sign in button. Find the value key. Just find by key. And then let's use value key. And then we want to use a value key. And let's find this button, this sign in button. It's using a value key of sign in as well. So let's use that string here. So this will be the sign in button. And you want to click on it. So there are several gestures that you can use. One of them is tap, so driver, tap. Just provide the finder. So this is an asynchronous method. And maybe we want to try this now. So you just find the sign in button and tap it. So what we expect is the test will run this, and we would end up here. Compiling the Flutter test takes a while, so we might want to run it now and just wait and explain things to you while it's trying to compile. So as you can see here, afterwards, we would need to enter the email. And to enter email, we need to find the email field, find the email field, tap on the email field, and then the text on the email field. For text fields, it's a common pattern where you're trying to tap it and enter text. So I made a convenience method here, an extension on the Flutter driver class. called type, provide a finder for the element, and the text to type. So it just what it does is it just tap on the element and then enter text. So these are actually existing methods in the Flutter driver. Just enter text on the current widget that is active in the currently focused text input. And it's just a shorter way to add it. So now I think the test will be running in a few seconds. And then after you type your text in the email field, you'll do the same for the password. And then we need to check if we are logged out. So hopefully the test runs now. The test failed actually. Tap the scroll button. So it cannot find the value of this. So let's go through the existing already. Let's find all the finders. So let's just use the finders and use the sign in finder. Actually, the test didn't run because we didn't run the application. We're missing this test setup all. So it's important to connect the Flutter driver to the application using this command, Flutter driver connect, and wait for it before you add any tests. So now that we've added the setup all method here, I've added an extra code here, which is to wait until the first frame has been rendered. This solves some issues when your driver runs before your application so that your test is more reliable. I found this in a GitHub issue in the Flutter repository. Let's try it again. This time we expect it to run and click on the sign in button. Some other finders that I have here is to find the login button here using text. And then here also the value, and later on there will be an alert dialog, and we find the OK button there using this descendant method. Hopefully the test does not compile too long. Before it ran around 1 minute, I think we can go on to some of the keynotes points here. So right now we're using by key only. There's also by semantics label, which you can add to tooltip, or via the back button in the widget, or via an ancestor, which will find your widget if it is the parent of some other widget. And the descendant methods does this the other way around. So you provide a widget that is a descendant, that is a parent of the widget that you're trying to find, and then you provide a finder for your widget. So this sum is the parent, and the finder is the widget you're trying to find. And as you see earlier, you can also use the find text method to find a widget containing some text. Only works for some widgets that have text, such as text, and I think it also works for the fields. You can also use type to find the widget, or the actual instance of the widget if you have it. You can also create a custom finder by using match finder and extending it. For example, we can add a method called find.log as an extension to find, and hopefully we get something. And once we go back here, it seems that it has successfully run the tests since we ended here. So let's go through all of them really fast. We've already tapped the sign-in button. We want to enter the email field here. So once we've done that, we'll wait that type the email. We have the email finder here using the DroidKaigi and some text. I think we have some sample email. And we want to do the same to the password. So after that, you want to check if you're logged out. There are several ways to do this. First is if you have an instance of the state where you contain the value where you are logged in or logged out, you just check that. Or if you have the application here, you can send a message to the application. So there's a thing called a handler here. You can add it to your driver, a handler, data handler. That will allow you to talk to the application from the driver. So you can say driver .send command, and the add is something that we need to handle as well. So for example, if we say that when we receive a message called sign in with email and password, we will return a string of the login called variable here. Why is it a string? Because enable Flutter driver extension only accepts the data handler as a string. So it's a function accepting a string message and returns a string response. So let's try calling that here. And it should be this logged out. Simple. Let's check my autocomplete. Let's call it request data. So we request the data and we expect it to be false. So this logged out is a string, which should be false. So here we're trying to test if we are logged out, and I just see that. So here we're trying to request data using the handler here. But right now, it will just always return false. So what's the right way to do this? First, let's try to click on the login button. So you want to tap the login handler. And when you tap it, it should call the network, which is not what we want. So what we want is to actually mock the network using some other library. So to mock that, we can use Mockito. But first, let's go through the gestures that we can use. We saw that we can use tap or enter text. There's other gestures such as drag from, fling from, and using tap and enter text. And let's go back to mocking. We have Mockito that we've already added. And then we want to stop the network calls. Let's do that. Some this method here. And what we want is to have the clients mocked when we call logged in. It should answer false. And as you can see, we're typing, and then we're trying to log in. And we got an exception because we're using Firebase for login and storing of data, and it's actually using the network. So yeah, we definitely don't want that. And for mock client here, we need to define it actually. So we just create a mock client. And then you also want to mock when you sign in, you just call login call history, and then return a mock result. And when you get the user after you've logged in, you want it to return an actual user. So there's that with login call, the actual user. If not, return. So that should handle logging in. And how do we set this mock client to be part of our app? Well, I've exposed the state of the app that you can modify. So first we create a state and set the client there as the mock client, and then provide it to our app. So this is just how my app is structured. You can use several other different ways, such as dependency injection, to replace actual variables of your app using mocks. And then I've required my state to know if it's testing or not. So I just add this one. So this is specific to the app I created. Something you can see here is when you've already mocked this and you've already called this, I think it should already work, since this is already logging in, but we're still not verifying if you're logged in or not. So let's just see that when you're logged in, you will see the page where there's a list. Let's run the app too, so you can see that. And what you want is to log out after you're logged in, because when you're logged in, you know that you can log out. So that's how you verify. You can also verify if you request the data that when you're logged in, this is true already. By using the same request data command. So here you can actually test if you're able to log in. Let's see if this will run first. So going back to the slides, we can use an abstract class, as I will show you in a while, to replace the methods and mock that, and then replace the instance in the app with the mock. For example, the app I'm using is using Firebase for networking, and for that, I have a repository that contains all the methods that call Firebase. So here, for example, the one we're using earlier is just sign in with email and password, and then we get an auth result, which is a class from Firebase. So here, you don't even need Mockito to make a mock. You can just extend this class and implement the methods. But to use Mockito, it's easier actually, so I'll just use that. And then after you've created the abstract class for your methods that call the network, you can create a class, something like this, for signing in. And then in your app.dart, you can use Mockito, which I've shown you earlier, to mock the sign-in with email and password. And then you can set a variable, which you can request later on with the request data method. And then you can return a mock result. Let's go back and see. Okay, it seems like it's tried to log in already, but it's still not using. It's still not using the responsive, because we failed to return user here. Let's not listen to this. So what I failed to do here is when after logging in, it calls get user, and then if we are logged in, if it returns null, it doesn't go into the main screen. So I'll just fix that, and let's see if it gets called now. Afterwards here, we can move on to the others method to test sign up after we made the logout command here. So what you need to do actually when you're trying to log out is click on the hamburger icon, which is on the top left here in the drawer. Click on it, and then there will be a logout button. It will show up, and then you click on that. So we'll see that in a moment. Probably skip some few seconds here while waiting. Very good. So now we're actually doing it. That is done. Okay, now we've logged in, and the problem now is that after the test is finished, it doesn't log out. So we want to clean that up before running the next test. So you want to click on this, hamburger new, and click on that. So to do that, just drive the tab. We're using a special thing here where it's using a tooltip. Open the navigation menu. It's already provided in Flutter. You can see I didn't put it in my code. So that's a Flutter specific thing. Actually, that's with the task already. There, we've created our first integration test. Really good. So now we'll be confident that users can log in when we run this continuously. On the other hand, we still haven't tested sign up. So let's just add it here quickly, since we're doing the same thing. We are first tapping on the create account button. We enter some text here, it's the email, and then tap on next. And then after that, there's a password screen, and then we tap on the next line. So let's add these missing finders. So here we need the create account finder and the next button finder. We're just using text for the next button finder. And the text field finder, we're using the type finder there. So to find this, we'll be using by type and just use string for the class. So here we have the test for both sign in and logout. Let's see if it runs properly. And we will not wait for it to finish, and we'll just go through the screen. So some common problems when you're trying to run integration test is it times out when finding a widget. We've seen it earlier. We were trying to tap on something, tap, and it was called on nothing. This is actually not a timeout error, but if it cannot find a widget, it will throw a similar error. And a solution for this is to make sure that the widget is there first, or to add some waiting function, such as the method here I've added on setup all, because sometimes the driver runs before the actual app. Another common problem is you're missing directionality. This happens when your widgets are not wrapped in material widget or another widget that provides directionality of the text. Since when Flutter tries to render your application, it has no way to know if the text goes right or left. So you just add a widget that has directionality information on top of your application, and then the problem is solved. Another problem is that there is no root widget attached. So this just happens when you forget to run the application. It's just the driver running. And this is not a common problem. This is actually the behavior of integration testing in Flutter, is that it does not reset after the test. You can probably see that here in advance. You've seen that some of the tests failed. What happened here? Shows false, which is different. That's because we did not add a mock for the create user. So let's create, well, actually, it's missing the handler since it didn't get the string here. So let's add the missing handler and the missing mocks. So we'll mock the network call when you create a user. Random testing. So yes, when we run an integration test in Flutter, after it finishes, it does not reset the app to the initial state. So you would have to do that yourself. And for that, we were using logout here on the login test. After logging in, we log out to clean it up. And after we sign up, we tap on the back button so that it goes back to the main screen. After that, we'll be moving on to widget testing, but let's see if it finishes first. Let's just go back to widget testing. So you've noticed that after you have implemented your sign-in logout tests, you still have to test a bunch of other features. One is to list your watch movies. So you want to know if this is rendering properly with the text in the year, and even if it shows up in the list. And then if you can add, for example, or if you can filter your search history or search for items when you're trying to add. So right now we noticed that running the integration test takes quite some time. So it takes around a minute for it to actually run. And now you can see that it will run. So first try to log in, log out, try to sign up successfully, and then log out. So that's a complete cycle of the integration test. But it takes really a long time for it to finish compiling. And something faster that we've shown earlier in the table from Flutter is widget testing. So now let's try using widget testing to cover the rest of your features so that you are more confident that your app will not break and you wouldn't lose precious memory when you've watched My Little Pony last week. So when should you use the widget testing? First, you can test a specific UI element, for example, this row here. So this is a class that I made, is one widget. You can test that widget only, so without the whole application. You can also test, well, specifically a stateless or a stateful widget. And then you can also test the whole page of the app. So as you've seen earlier in the integration test, you have the login page. It's one whole page. You can also run widget testing there, but it will lose all the other running things in your application. So if you initialize the login page for widget testing, it's only that. There's nothing else running unless you provide the whole application to your widget test. And I'll show you later how you can test navigation when you are using widget testing. How do you set up the test now? So for widget testing, you add the Flutter test dependency. You can do that here. Flutter SDK. So now that we've added that, we need to create a widget to test. We already have an app, so we don't need to create a new widget. We can try to focus on this movie item, list item widget. So this is one widget that shows a list, an item in the list. And then we can create a test widget test. So I've already made a black, or almost black, test file here, which has the main application, a main method for it to run, some static variables and constants. And then we also have some blank test widgets. So these are the test cases. First, I would want to test if I provide movie one, the sample movie, that I will be able to find the widgets using these finders. So I'll just be using all the finders and test if they are able to find it. So the next step is to build the widget using the widget tester. So we have the test case here. We want to build a movie widget. This item, we provided a movie, which is the sample movie. And then we want to the tester method here, which is the widget tester. It's coming from this tester here, from the test widgets method. And then you can pump the widget, which is actually to provide a widget to the tester. Right now, we're pumping it with this widget. So right now, we're not going to do any tests, but let's just see if it runs. It should be rather fast compared to integration test. Okay, it's actually failing, but it finished compiling. So you see it's much, much faster than integration testing. And here, the test was that it failed because, let's see, some rendering issue. Directionality widget requires directionality widget ancestor, something I've discussed earlier for integration testing, and that this could not, the text could not find directionality widget. So in order to solve that, you need to add a directionality widget. And I've already made a method here that provides us with the directionality widget. So here I'm just specifying a left to right text directionality widget and just making a window so that there's a constant size that we can control for the widget, and then adding a material component on top of it, and then adding the widget itself. So once you've had this method where you can specify a directionality to your content, then this test should not fail anymore. But we're actually not checking anything. Just want to see if it passes, and it passes. It takes around 3 seconds to finish, much, much faster than integration testing. And we're testing actual UI here, so that's really good. And what we want to test actually is if we can have the, I'll show you first once we start running the application. If we can check the name of the movie and the year of the movie in the display. So what we want is to pump it and then check if does the name exist, does the year exist. You can do that using the finder here, search for the widget, and then you can verify using matcher. So matcher is something new compared to integration testing. It didn't exist earlier. And we'll go through the types of matchers on the next slide. And then you can run. Well, we've already run it, as you see, with Flutter test. With matchers, you can use it to find one widget. For example, if you have here, you can test if it, so run to expect if the finder actually, the finder for, then it finds one widget. Since this is a matcher, so this expect method, you have the actual, which is a finder, and the matcher. So if once you have the finder for the name of the movie, you want to match that it only is one. so that it passes. So let's remove all of this and test that I prepared earlier. So here you can see we pumped the widget, same as before. And then you can expect to find the number of times you've watched it here. That's 1. That will be just a widget. And then, so we're just trying to find the widgets. We're not actually trying to find the content for this one, for the watched times and for the year key. And then we also want to find the text. So if you have a name of the movie here, from sample movie, you want to find it, one of it. And you don't want to find the other movie, which is movie name 2, provided in this other movie that we didn't really initialize here. So it shouldn't exist. And we also want to find if there's one image widget existing, and if that image view instance is there. So since we have access to this variable, we can just use that to find the actual widget itself. It should be 1. So let's see if it runs. And it passes. So you're able to find the name of the movie. And let's see if the test is actually working by breaking. So you can see that it's not just skipping the tests. So I modified here this find text movie name. It finds nothing. So now it should fail here because you have the movie name appearing on the widget. One problem that you can see when running widget tests is that you can't see anything. See? So it failed because it can't find the widget. Let's see description, test description. It's this one, and the failing condition was this. So it expected that there's no matching nodes in the widget tree, but then actually I'm trying to find this text. This is the name, which is the name of the movie. Here. It's actually able to find one. One was found, but none were expected. So yeah, we're actually testing this widget if it existed. So going back to the state of the test where it's passing, it's actually verifying this movie name exists. It should pass 3 seconds, very fast. And so one problem you can see is that we can't see anything running. Doesn't run it in the simulator, only runs it here on a simulated environment. And the problem there is that it might be very hard to debug. But luckily, you can debug it using this one. So you can run line by line and see if your item row will contain the actual movie name itself. So now we have an item row, we have an image view here, we have the item itself, and yeah, there you can debug your widget tests. Just find it. So you can do that as well here. Test with another item. So here we're testing the other movie. You did not watch it yet. So, I mean, you've already watched it once, but not more than once. So the watch times here should be blank. And the only other thing I modified is that the watch times widget finds nothing, and it should still pass. Yeah. So going through the slides again, you have finds one, finds nothing, finds widgets, so multiple widgets, and finds n widgets, which is, you can specify the number. So finds widgets is just finds multiple widgets, like one or more. And then finds n widgets is the exact number of widgets. So you can have that later on. And you can also use the other matches in matches.dart. Maybe you can also create your custom matcher and extend from the matcher class. You can also use Mockito in your widget test, similar to integration test, and you can also mock the navigation. Let's show you that. So I think this one has the mock navigation. So when you're trying to add, let me show you the app itself. So what we want is to have this way of verifying if you are trying to add a movie that you've watched, search from the list, so it involves a network call. You would want to mock that. So here I provided a mock to the watch movies call, and then to answer nothing. And then with that, you can create a mock client. So find mock client. I didn't make that class yet, so let's use Mockito to create a mock client class. This one. Yeah, we want to mock this abstract class that provides the method to find the movies. And let's create this class. We also want to build our whole page. So for that, I've created a method that builds a material container that has the movie list page, and it can also have a state attached to it. So let's expand this build material method. And what it actually does is it just builds the app from a window of this size. So you can provide the size here. And this build material method is coming from my app just to build the material app. So it returns to me the material app instance itself. So here we're actually testing the whole application. And we also provide a fake user here and some observers for navigation. So as you can see here, I provided navigation observers. And it goes to here. So the material app can have navigation observers, and it gets triggered when you change navigation. So for example, once you've added your movie, you want to know that it has pushed a new view to your application. So that can be achieved by mocking the observer here provided. So you just make a mock observer. Do that again with Mockito. So just change observer. It should be a navigation. So what is the name of that class? Let's see. Navigator observer. So now we have an observer. We're just missing the state of the application. So this is specific to my app because my pages rely on the state. As you can see here, using the provider pattern. Because when you're trying to fetch your data, you get it from the provider and then you call the client. So it's because the client is inside of the provider here. So the repository where you can find movies or log in or add movies, they're all in this provider. And for that to work, I need to wrap my widgets using the provider pattern. And we need a state here. So let's just create that one. Actually, we don't need to mark it. We just need to instantiate it with the macro. So instant provider. We just provide it with the client. So now we have all the methods required in Mux required for us to run this test where we are able to add. So the app is still building. Let's see if it will finish before we run the test. Let's try to run the test. So what's happening here is you pump the widget containing the movies list page. You wait for it to settle down, and then you tap on the adding button. So what we're just trying to see here, if it will push a new view to the navigation. So we verify that in the observer, we called it did push something. So something should have appeared. So we're actually not testing anything regarding adding, just showing the adding. So that takes care of testing navigation for widget testing. Okay, let me see more. Semicolon. And that's the demo of the widget testing. Let's just compete until it finishes. So now I'm trying to add, so fast. So what's happening actually here is we just opened the page, which hopefully will compile soon. So I can show you there. It's compiling, it's running. I'll show you the page where you can add. It's the debugging. You have your watched documents, and then you can add. So we were testing this part where when you click on add, it will show you the page. But yeah, we didn't check if the page appears, we just checked if navigation happened. So one more thing you can test is when you've added, for example, you've added something like a Flutter movie again. You watch this. Something. Okay, so I've added that. And it appeared. So let's add one more. Another Flutter movie. This one. And it should appear here. So what we want to test again is if we are able to search. So this part where we type space, Odyssey, and filters. Odyssey or Flutter. We want to test that as well. And in order to do that, if we want this, we want to load this again. So we want to load the movie list page again. And then when you type here something, it should show just that item and not the rest. So let's have this already pre-made test load here. So again, when we fetch the watch movies, we want to return nothing. And we want to be able to find the widget here. Let's try if it works. So what we did was to mock the network call, the response. Actually, I think we're missing some data here. Should be full of sample movie, and movie did not watch it. So we pump a widget, the movie list widget, wait for it to settle down, enter text in the search placeholder. So we're using the bounce text field here. And we use the text inside of that here. Search your watch history, so that's the placeholder to find that specific widget. And then you want to wait until that's finished. Then you need to find the text where you are searching for this. So we just tested if when you type here, your text appears. So not actually filtering stuff. And then another thing is if we drag on this, we want to know if it loads the bottom row. So if you have a lot of stuff, if it's full of new movies, then you can have the bottom row show up. So if your screen is full and if it's scrolling down, then you want to know if the widget still renders here when you scroll down. So what you want to do is have some items when you call watch movies. So here we have like 1, 2, 3, 4, 5, 6, 7, 8. And at the bottom we have the other movie with a different name. And again, we pump it with the movie list page, wait for it to settle down, find the item with the movie name, finds widgets, multiple, and we're using the find n widgets now with 0. So we shouldn't initially find any kind of widget with this second name here, which is this movie name 2, because the first page does not contain this item, movie without watch. Here. The number of rows that is visible depends on the size of the view. And the size of the view, we provided it here in the build material container. And we are trying to build it with a media query. So the window here comes from this, and there's a default size that you can find out later on. You can also provide your own widget size here. So after the first initial scrolling, initial appearing of the page here, you would want to have the last row to be just to try out this method, we're trying to find the movie name. And then you want to drag from the last row upwards. So you want to drag the last row upwards like this, or something like this. And then wait for it to finish rendering your content. And then you want to find the second movie name. That there should be now some widgets. And I think this belongs to the other text. So let's run that, and it should finish very fast because we know that it works here. And it passed within 8 seconds. So widget testing is really fast. And some common errors that we've encountered is that there's no directionality widget that can be fixed by wrapping your widget in a directionality enabled widget. Another is when you are rendering and it overflows the view. So you can do that by specifying the size of your view and or fixing your widget rendering. Because sometimes you are trying to get all the space available, and then you should have only like a specific amount of height and width. Or actually it could be fixed by providing the media query to your view, such as here when you're building your widget. So media query should solve that. And for example, if you are navigating, could not find a generator for the route, then there's a problem in your routing, and you should mock your routing if you want to test your routing here. So now that you have tests, is the next problem is in your vision you want to run this test all the time whenever you make a change, and that can be done with CI/CD. And one of the best ways to do that right now is via CodeMagic. So I've added the app in CodeMagic here with Bitbucket. I just imported it there. And then you can see some settings here on the right side. You can enable the Flutter driver test. You can also just run the Flutter test. So here, as you can see, the Flutter driver tests are enabled, and also the normal test, which will run both unit and widget tests. There's also a way to specify how you build the application there. And I only want to run the tests. I don't want to compile Android or iOS. And then when you run it, it shows you how much time it takes. Testing took 13 minutes. I think it's because the integration testing takes a while to compile. And then its status as well, which is successful. And then you can also see the logs there. And you can see that the first is it tries to run the integration test to show you the logs, running the driver, what installed building, and then trying to listen to the app, and then performing the setup, performing each test, and the teardown. And then if your test has completed successfully or not. And then after the integration test, it runs the widget test. As you can see here, finishes really fast. And at the end result, as I've shown you earlier, is this. For integration testing, we can actually make it faster than this using time dilation. So if you have this, you can set the time dilation property of your application, set it to a really low value. I just found that this value is pretty good enough to make it as fast as it can. And it could be really fast. So this one lasts around around 8 seconds, and much faster will be like this, it's 3 seconds. So that's another advantage of the time dilation property. But still the bulk of your waiting time will be to compile the integration test. So right now we have the no unit test, but integration test. And usually when you add just unit test, this is what will happen. So you can throw your trash, but when you're trying to dry your hand, it flies away. So we've prevented that issue with adding integration tests and widget tests. Here's some further reading if you want. The link to the slides will be provided. And there's another thing that Flutter is using. So the Flutter team is using something called golden file test. They're trying to render the widgets, making a screenshot, and then comparing that screenshot to a golden file, which is the reference. So this is something similar to screenshot testing. And if you want, you can read that here. I didn't go into detail on this one. That's a pretty interesting one. And you can also access the project that I was using, the starter project here, and the finished project here as well. So that's the end of the presentation. Thank you very much. And if you want to get in touch, just check out the links. Thank you very much and have a good day. Bye.